Welcome back for part 2 of building a 2D farm game from zero. We finished part 1 with implementing basic collision and collision interactions. Next, we're going to add some basic movement animations and start implementing our soil tilling behavior. If you missed part 1 but want to dive straight in, you can find the source code for every part on GitHub with directions on how to find the part that you're looking for. Let's get started with some animation. Now we could do this by changing our sprite 2D to an animated sprite 2D. But what we're going to do is actually add an animation player. And the animation player is capable of doing everything the animated sprite 2D is, but we have some additional features such as adding sound or changing other properties. To get started, we'll just click on our animation button here, and we'll create a new animation library for our player. Select OK on that. And now when we come over to animation new, we can select our player and implement our animations. So let's select our sprite 2D. And you can see we have little key icons next to our properties. If we go ahead and click on frame, you can see that in our animation window, we have added a keyframe for the specific frame of the sprite. We've only got the 2 frames, so we'll just select right in the middle and add another key. But be careful, don't expect these values to correlate to the keyframes. If you click on the keyframes, you can see our value here is actually 0. So the first frame for our down walk is going to be frame 2, and the second one's going to be frame 3. And in order for this to correctly play, make sure you have animation looping enabled here. And this looks good, but it isn't quite fast enough for our walk speed. So let's go ahead and adjust that. To make this a little easier, I'm going to adjust the timeline from seconds to frames per second. So our total duration is 30 frames, which obviously is going to be the 1 second. Let's drop that down to 12, and it can be any even number. And then again, we're just going to adjust our sprite to the middle frame. There we go. Now he's moving. And then quickly implement the others. Just to make it a little easier on you, I've gone ahead and put the indexes up for all the animations. With our animations set up how we like them, we can go ahead and start implementing the actual movement. So I've already populated the code, and let's step through it real quick. First thing is new is we're going to need to get our animation player reference, and then we just added an easy little template to make accessing the animations by string a little easier. Down in our process function, all we're doing is simply looking for an action and then applying the animation that corresponds to that action. It's important that this isn't an if-else-if statement because they are mutually exclusive. We don't want to be animating 2 directions at the same time. And then most importantly, if there is no action being performed, stop any animations that are ongoing. Let's see if our work has paid off. Ooh, off to a good start. Cool. Oh, looks like our down is messed up, but all the other directions seem to be working. Let's figure out what's going on with our down direction here. Oh, we just didn't adjust the frame. Let's go ahead and address the sorting issue we've seen with the walls in our character. So if we select our character here and hit W so we can move it, we have this effect where we should be in front of the door here. Well, the first thing we need to check is to make sure that our Z index is correct on both our door and our player. So both of our Z index are on the same layer, which again means that sorting comes down to their position in the hierarchy. But obviously we don't want to move our player node above and below our door whenever we want to change that perspective. So what we can do is enable Y sorting on both our door and the player. Now if we move our player, we can see that there's still nothing happening. And that's because we have to enable at the very top level Y sort enabled. And after enabling that, our character is correctly in front of our door here. And if you look at this little cross with the circle in it, that is the point at which that sorting will change. So if we move our player up to this center point, you can see that when those align is when that sorting point changes. But we're not quite done. We got one more thing to do on both the door and our player, and we'll need to adjust the point of our Y sorting. Currently the sorting point is in the middle of our character's face, but leaving it here would mean that once our character's face passes an object, our entire body is then sorted behind it. So in order to adjust this, we're going to click on our sprite 2D because this is where the actual Y sort is being implemented. And you'll notice there's no way to adjust the Y sort here on our player node. And that's because what's actually being sorted is our sprite 2D. So if we click onto our sprite 2D, we can see we have an offset option. We're just going to adjust our Y position so that our Y sort origin is at the feet of our player character. We'll go ahead and round that down to a even -8. With our sprite being 16 by 16 and the Y sort originating in the center, all we have to do is shift it down by 8 pixels, and then we just need to follow up and do the same thing with our door. And you can see that it's moved our entire sprite here for our door, so we need to move that back down, and we may need to adjust the collision shape. Nope, that's good to go. We'll need to check the collision shape on our player as well. I've got it hidden, but if we toggle it visible, we can see we need to make an adjustment, bring that up. And let's check it out real quick. Okay, perfect. All right, it's looking good. There's a little bit of weirdness as we're walking through the door here, where you kind of go through. But I think that's solved more with timing of the animation and the collision shape removal. All right, now that we're not hoverboarding everywhere and our house feels like a house, let's start farming. Now we're gonna need some more land to work with here, so we'll go ahead and expand our tile map and add some more grass to our terrain. There we go, that should be plenty to work with. We're gonna want the player to have the ability to till dirt at runtime, so the first thing we'll need is the logic to determine which tile is under our mouse. And in order to get the tile data, we will need to access the tile map layer. So we'll go ahead and attach a new script to our terrain. And here we will override the node input function. Now converting from local position to map position to global position can be a little tricky. Thankfully the docs do us a solid in this situation because ultimately we're going to be calling get cell tile data. And if we go look at this in the documentation, we can see that it's going to return our tile data if there's anything there, but it also gives us the implementation that we need to get the correct tile. Our code will look a little cleaner since we don't have to reference the tile map layer. So we'll just define a variable called coordinates, and we will say local to map, and we're going to get the global mouse position. And the global mouse position will take into account the entire scene instead of just the viewport. I've learned the best thing we can do for ourselves is set up a visual. Early visuals prevent a lot of frustration. So next we're going to render an overlay underneath our mouse position. So let's hop back to our scene view real quick. And I've just quickly put together a little overlay sprite in Asprite, which we've got imported into the assets folder here. We'll need to add a new sprite node so we can render our overlay. And this could be done with a texture rectangle. I don't know that there's any performance implication, but using a sprite 2D makes it easier to position since it's already centered. And just like our player sprite, we'll just drag over the texture. And it looks like we're going to have to adjust the positioning. Right now the overlay is a child of our terrain tile map layer, and for now that's mostly for convenience since that is where our script is attached. But obviously we want our overlay to be rendered on top of the other objects. Because I'm not entirely sure of the final structure, I'm going to avoid adjusting z-index, and I'm instead going to piggyback on the canvas item top level property. And you can see our sprite is now rendering at the correct layer. And we'll rename this node to tile overlay, and we'll set the initial visibility to hidden. With our visual set up, we can go back and implement the rest of this function. We're going to get a reference to our overlay. And the onReady decorator is just some syntactic sugar, which means it's a nice terse alternative to a common language pattern. We've got the coordinates for our tile in map space, but first let's just render our overlay wherever our mouse position's at. Now currently our input function is going to respond to every input event, keyboard, mouse, whatever. But we're only interested in updates to the mouse position, so we're going to check to see if our input event is an input event mouse motion. And ignoring our coordinates for now because that is in map space and that'll be for our tile, we just want to position our overlay under our mouse. Now this function is going to be evaluated a lot, so we need to keep performance in mind, as we always do. And what we can do is defer the setting of our position property. And this is a pattern you'll find throughout the Godot documentation. The setDeferred method comes from object, which is the base of everything. So in most cases, you should have access to the setDeferred method. And we can go ahead and remove this pass at the end here. Let's play this. And if you're anything like me and using the engine IDE, you'll forget if it's 2 Fs or 2 Rs. Let's try that again. Oh, and we can't forget to make our tile overlay visible. All right, the expectation is that it should be centered on our mouse. Awesome. Okay. But right now, this overlay doesn't have any value. The value of using this overlay is to give an affordance to the user about the tiles in this invisible grid. So let's implement some grid snapping. I couldn't find any methods in the tile map layer that would give me a nice box to snap to, but again, Godot has us covered. If we look at the global scope documentation, there are 3 methods here for snapping. And this just goes from least to most specific. So we have a method for integers, for floats, and then we have the snapped method, which is what we're going to use. And this will just simplify it so we only need to make one call. And I'll spare reading you the description, but if you look at the last line in the example, you can see that a vector of 3470 and a vector of 88 returns 3272. So it's taking our original vector and finding the closest multiple to the number corresponding to the other vector's position. Let's see if this does the trick or it's too good to be true. Let's define a new variable for our snapped position. And then we're going to want to snap our mouse position to a grid that aligns to our tile size, which is going to be 16 by 16. There we go. We've got some snapping. To make this a little more resilient, we can change our hard-coded values for the texture size and use the overlay texture itself. And in order to support tiles with uneven dimensions, all you need to do is multiply it by whatever those dimensions are. So now you can see we're snapping 3 across, 2 down. Now that we're set up to place our tiles, we're going to need a new tile map layer to place those tiles on. And of course, we're going to want that above our terrain, and we'll just rename this to dirt. To keep it simple, we'll just reuse the same tile set we have been using, and we will just add a new terrain set to it. Obviously, we're going to call it dirt, and that's fine color. So we've got our terrain, but no tiles to go along with it. So let's click into our tile sets here. We're going to open our Sproutlands assets, tile sets, and there are 4 different options here for tilled dirt. I'm not sure in what ways these differ, but we are going to select the tilled dirt wide because it appears to be closest to the grass texture that we've already done. And assuming you're here to learn, I would be remiss not to leave you with some exercises. So instead of going through this process again, I will leave this up to you to do yourself. And if you get stuck, don't forget there are references for the bit masks included with the asset pack. And I've added this new set to the second terrain set as structures and dirt are going to be above grass. This logical grouping will work for me. And with your new terrain set up, we can get into the implementation of tile placement. So for this one, we're just going to check to see if the input event is an input mouse button event. And this next check will come down to how you want your game to behave. But to keep it simple, we're just going to check to see if our event is currently pressed. And if we receive this event, we will need to make sure that there is a tile at the location. We're not going to be checking for dirt tiles as that's what we're trying to place. Instead, we'll consider a tile valid if there is a grass tile present. So let's minimize this. We'll go grab the coordinates from this other if statement where we're not using it. And we'll use those coordinates to get our tile data using getCellTileData. And then if data is found, then we are going to want to place a dirt tile. To make that possible, we'll need a reference to the dirt tile map layer. Now, the beauty and the curse with scripting languages is that they are flexible. So while you can do fun, creative things, you can also absolutely program yourself into a corner that's going to be tough to get out of. So what I try to do is only use this node reference path when it's a known, unchanging child node. If you need to access a node that's not in the current subtree, I'd recommend assigning it directly to an exported variable. Alternatively, if you have a node you know won't be duplicated for any reason, you can define a unique name on that node type. So using our onReady syntax again, we can reference our unique node with this syntax with the percentage sign at the front, and then the node name afterwards. Now that we can access our dirt layer, let's go ahead and implement the placement of our tiles. So we're going to use a method called setCellsTerrainConnect. And making a call to this method is like using the connect mode paint tool. Check out the documentation. We see that if we just provide the terrain set, the terrain, and which cells, it should take care of connecting the tiles. So we'll pass the coordinates from our mouse position, and our terrain set is going to be 1. It's our second terrain set, and the terrain also going to be 1. And we should have the ability to place our dirt tiles now. All right, cool. But something's off. Looks like our dirt tiles are drawing to the bottom right. So it looks like our world coordinates and the tile map layer coordinates are slightly off. We need to go adjust that. And the first thing we can try is to just adjust the position of all nodes. And if we hit play on that, we can see that solves our issue. But now we've got a brand new warning on our top level node. And it's just warning us not to transform the root node because it could be modified dynamically. So we'll go ahead and reset that, hit save so that warning goes away. And our alignment issues with tile maps, so it makes sense that the next thing we would try to adjust is our tile map. So we're just going to pull this to the left and then up. And with that, looks like we'll need some minor adjustments for some other objects, but let's see if that does the trick. Okay, there we go, that's working. Now we can go ahead and adjust our door, and we could call this good. But there's a sneaky gotcha that happens when you have Y sorting enabled and you adjust the position of the transform. And we can see this in action if you select the structures tile map layer and then you move it up 1, it disappears. But why is it getting sorted behind terrain in the first place? If we look at the ordering, we don't have Y sort enabled on that layer. And this just comes down to the Y sort behavior applied to a hierarchy. So because our top level node has Y sorting enabled, every child node of our root node will automatically have Y sort enabled. So even though we don't have it explicitly checked here, this node itself is Y sorted. Now because we don't have Y sort enabled on this node, that means our tile overlay is not subject to the same Y sorting. So let's recap. The top level node, if it has Y sort enabled, all children underneath it, each of these nodes are going to be Y sorted. But then if that child node isn't explicitly set for Y sort, any of its children will not be subject to that same Y sorting. So we don't have any kind of opt-out option in the UI here, but with that child-parent relationship in mind, we can add a buffer node in between our node 2D and our tile map layers. So we just select all of these. We're going to reparent this just to a new node 2D. We'll just go ahead and rename this tile map. So we don't have a first-class tile map node, but now we've got a node container that's effectively acting as a tile map with its individual layers. And quickly reviewing this again, we have Y sorting enabled. We have no Y sort enabled here, so it won't force any children into that mode. And that's exactly what we want. That means that all of our tile map layers are now decoupled from that top level Y sort option. And while our door is not a tile, it's annoying to have to adjust its position, separate from the entire tile map. So what we can do is just drag this under our structures node, and now the door position will be relative to this position. All right, that was a bunch of acrobatics there. Let's see if we're still working. Awesome. We dipped our toes a little further into animation, implemented some mouse event handling, and implemented some dynamic tile placement for our dirt. In the next part, you'll learn how to define a world clock, and then we will go through the different growth phases of crops. Catch you on the next one.